Following Graham's very interesting thing about how big microservices should be, I have to say I was nervous of covering some common ground because some of the stuff I touch on is similar, but fortunately I think I can tiptoe around the minefield. I'm going to talk to you about microservices and Akka. So basically, these are the topics I'm going to cover. There's quite a few of them, so if I find myself talking too fast, somebody go slow down, because I can get excited and I can talk too fast. I'm going to talk both about the technology and the core concepts. I'm not going to basically assume that I'm doing a primer on microservices. I at least expect you to have some understanding what the hell are microservices that you hear, because otherwise I'm going to bore half the room if I start as a primer. And I really want to give you a flavour of what the technology I'm talking about, Akka, can do for you if you're building a microservice. And I'll also talk a little bit at the end about what I've been building with Akka, the team I've been working with and the company I've been working with. But I'm going to sort of be back to front to you, and that I'm going to approach it from the point of view of the technology and then get to what we've been doing. So who am I? My name is Robert Boothby, big letters there. My current job title is as Agile Architect at Icon Solutions, and frankly I invented that job title. Basically, I've not seen anybody else claim to be an Agile architect, but I believe it's a really necessary role in Agile teams, that an architect is not afraid to get in there with the developers, with the DevOps, with the testers, with the business analysts, and really understand the problems that we're solving at a really fine-grained level, as well as bringing in the meta level, why the business is doing things, what's the shape of the business, what's the shape of the whole landscape that we're building this technology in. And I think the job is to bridge all of that while still delivering every single bloody sprint. Really, really key. So what have I done in the past? Why should you listen to me? Or maybe why should you ignore me completely? I led the very first Java team at BBC Technology. I was a technical architect for the UK Faster Payment Service. In fact, I was the technical architect for the UK Faster Payment Services at Voca, which became Voca Link, and then there were more of us, but hey, that's the way it goes. I was a team lead and architect for BAML, and a very dear friend and colleague of mine from that day, using direct domain-driven design for our global liquidity platform. It was the first time I used DDD. And very recently I was chief architect of Zap, which is a mobile-based, real-time, person-to-business, business-to-person, business-to-business platform. I'm a code geek. I love IntelliJ, and I just shudder at people using Eclipse, but you know, it's just the way I am. And I also have my lower level geekery. I love direct compute, GPU stuff with OpenCL. So I'm sort of a bit of a mixed bag. I consider myself a jack of all trades, and I like to think a master of some. So this is hopefully why you want to listen to me. So, Akka, what is it? It's fundamentally written in Scala. Scala, until very recently, has been purely a JVM language, though there have been a large chunk of engineering effort recently to make Scala a language that runs on its own virtual machine and can be deployed in different places. My main view on it is that in many ways it's an alternative concurrency model. It's based on the concept of actor architectures, and actor is does a single thing at a time. It's not multi-threaded, it's not concurrent, it's not anything. And it works on message passing, that you pass messages from actor to actor, and an actor has a queue of messages that it deals with. So in some ways, in many domains, this type of concurrency model is a very natural way of thinking about how you deal with multi-threading and all those other things, because the framework does it for you. However, I am going to point out some ways you can trip yourself up really badly, and it doesn't stop all the nasty difficulties of dealing with what happens if A happens before B or B happens before A. I say to everybody, when you're dealing concurrent systems, throw out any conceptions, the order in which things happen, because it never ever works. Other bits to do with Akka to mention, which we'll cover in some more detail, is that it's got a supervision framework, which is really interesting when you're building high availability microservices in terms of providing mechanisms for self-healing, but more on that anon. We're using it on the JVM. We're not really doing Scala. We're actually a Java 8 shop. So we're doing a lot of Lambda and functional programming with Java within the Akka framework. And there's a few little bits of impedances, but they're really beginning to go. The Akka guys have got a really competent Java API now, and we're doing basically everything we want to do. And some great extensions to it as well. It's very lightweight, but you can get clustering, HTTP and Camel, which is a godsend for what we're building. Okay? So, next, let's bring back now from the technology for a second and talk about domain-driven design. I mean, really, this is straying into Graham's territory, but it's something that is close to my heart, because a lot of the dimensions that Graham has talked about can actually be addressed using domain-driven design. So, fundamentally, I mean, it's one of these stupid questions that everybody asks, and every developer often isn't told clearly by the people who he or she are working with or for. You have the business analysts, you have the business owners, you've got architects like me, etc., etc. And actually knowing what the hell we are building is absolutely crucial. So a good thing I find with thinking about domain-driven design is that the fundamental is you as a developer should become a domain expert, fundamentally. You've got to know the domain that you're working with, and to know the domain, you've also got to know the wider domain. So the one thing that I say to every developer, and I try and bash into every single manager, code is cheap. Basically, writing code is really, really cheap in certain ways, because I can knock out 100 lines of code. But knowing what code to write, knowing the business context, knowing all the stuff, all the really hard lessons is expensive. Which is why I say the developers, the business analysts, you shouldn't be throwing them away because you've got documentation. They're the guys you keep, because they're going to be looking after you and your system for years to come. So the other things to say about it is that this focus on core domain and domain logic is at the heart of domain-driven design. So we're talking about, what is the core of what you're building. Domain-driven design acknowledges one real fact. Your overarching business has many domains. Basically, you've got the sales team, you've got the team in our world who are making the payments, you've got the operations team, etc., etc. Every single domain has its specialized, cohesive set of concepts, of concerns. There are overlaps, of course. You've got, things happening in that the operations team needs to understand what the core payment is, etc., etc. But they have their own concerns. Okay, so which is why immediately that starts to be, addressing Graham's thing, a way of breaking things down. It's really, really important. I mean, a really important trick from my perspective is that once you understand your domain, you're now in a really good position to start driving simplification and going to business, simplify what we're building by simplifying your business. Because often when you understand what the hell you're doing, you realize that they're doing a whole raft of wasted stuff, and you try and put it into a computer program, you're going to struggle. You're going to struggle badly. So a good other way of looking at it is to say, and I'm going to read a quote directly, a technical solution should only be as complex as the domain demands and no more. Being clever, being bright, creating genius stuff, not a good idea. So, okay, talking on a little bit more. Addressing on this is also a point to make is that the other advantage of domain-driven design is you can choose your solutions. Again, touching on that. You identify a domain to do with sales, for example. Why build your own microservice there? There are plenty of off-the-shelf solutions out there. You should select your solution to, bought off the shelf to integrate with your platform if you're building SOA or microservices, etc. But if you understand your domain, you're in a much, and your subdomains and your divisions of domains, you're in a much better position to choose the right technology. Right, so another thing to mention, we're talking about bounded context. We have a problem with domain-driven design. It's the elephant in the room when we're talking about it, at least in my experience, fragmentation. So you've split out your domains, you've isolated everything, you've said, great, I've got a microservice or even a set of microservices I'm building in this domain. Hang on, how am I dealing with the outside world? So touched on this, again, stuff that hopefully is bread and butter to a lot of you guys, but it's really worth mentioning. I'm not a fan of enterprise architects, I've got to say. An awful lot of them add very little value to the business. But that view, that overarching view of provided by enterprise architecture, context map is king. If you're doing domain-driven design, you don't have a context map saying where this piece of the system is fitting in. Me as an architect, me as a developer, us as, if we're doing business analysis or whatever else, to know who to talk to, who's responsible for these other closely related domains I'm going to be talking about, you're in deep trouble. For me, one of the first warning signs that something going wrong with the transition to doing microservices, potentially driven by domain-driven design, if you've got no idea who's responsible for the service that you're consuming, you don't know who to talk to from a development perspective, from an operation perspective, from a business perspective. So, just as a warning sign, if you see that where you're working, you know there's a trouble, flag it, shout it. Hopefully you've got a sympathetic person to let know. Right, finally, so moving on, the other way of dealing with the fragmentation problem is continuous integration. Can't hammer enough. DevOps, continuous integration, DevOps. The trouble with microservices, amply illustrated by Graham, 1,300 of them, you can't manage that without automation and everything else. We'll talk a little bit about what we're doing, but that's really important. Finally, the other thing that is very important coming out of the context map is your wider domain and cross-domain model in terms of messages that you're passing. So you need, for example, to say, okay, I've got the identification of a consumer. The consumer identification in one domain to do with the payments may be an account number or a sort code, but for a CRM, a customer relationship person, that's a much richer domain model they're dealing with, which is in terms of who they are, their name, and everything else. So within the domains, it's a classic example of how the data differs. But to maintain cohesion and make sure your microservices and your different domains can talk to each other, really important that you understand the messages that are being passed back and forth and make sure everybody knows what the data is necessary when you are joining things up. Again, avoid fragmentation because it is a risk. It's a big risk and you can fall into some deep, deep elephant traps doing it. Right. Final thing is just a pet peeve for me. I hate anemic domain models. I think the domain model, one of the reasons why you can see a lot of fragmentation is if you have a domain model, particularly cross-domain model, where the business logic is totally divorced from the domain model. So you end up with different validations or postcode structures. You end up with different rules about how an address is structured. Strongly advise where appropriate in your cross-domain domain model, the messages that you pass between them, how they are instantiated, whether it's using XSDs or whatever else. Make sure you've got enough context, enough richness in there that you have the ability to say, yes, we're doing common validation. It might be sharing Java libraries, it might be sharing .NET libraries, it may be sharing YAML and specifications and things like that. But make sure you've got a really rich view going on. Right. It's a little bit fragmented in some ways, but this is really how the various topics that come to mind, because this is a common problem I see with microservices. How do you integrate them? How do you join them up? Okay? And basically each group of domains and subdomains, and this is really something that's quite important to me, is microservices are very contextual. Ask an enterprise how big architect how big a microservice should be. He's going to give you one answer. Ask a developer the same question, he'll give you quite a different answer. But, how these microservices, the subdomains and domains that they represent interact is really, really important. So, obviously, we have a number of ways of approaching it. Now, orchestration, choreography, I don't know if you guys have ever made that distinction. Okay, and hands up, people who've made the distinction between the two. I see a nod from Graham, but he's an architect, so no surprise. So basically, orchestration and choreography are two ends of a continuum. So at one end, pure orchestration, you have a single central controller that manages everything in a particular business flow. That controller may itself be a microservice and may be coordinating microservices, but you know that A will go to B, will go to C, will decision to D or E accordingly, etc., etc. Very, very useful in that it gives you very deterministic behavior, SLAs. It's very easy to monitor, but it's quite inflexible and fragile. The opposite extreme is choreography, and this is very much more, oh, I don't know what I pressed there. Do you mind? Sorry, thank you. I think I pressed the stop button, I'll be careful with that. And so basically that's more the classic message passing where you're doing pub, sub, queues and topics, where you start introducing much more flexibility about how services interact. Rather than a service calling another service explicitly, you have a service picking up a message from a queue or receiving an unsolicited message and going, oh, what do I do with this? Very organic, very flexible, actually often much easier to manage versioning and upgrading and everything else, but your latency and your SLAs can be very tough to control and manage this. In reality, most microservices architectures I've seen, and most service-oriented architectures for that matter, use a mixture of the two without ever really thinking about it. But now you have these concepts. I mean, even as developers, within the microservices you're building and between the microservices you're building, think about, characterize the type of communication you're doing. Are you doing orchestration? Are you doing choreography? Are you doing synchronous? Are you doing asynchronous? It helps you understand the sorts of problems, the sorts of problems you're solving, and sorts of problems you're causing with your decisions. So Akka as individual actors, which may in your worldview represent nano or microservices depending, or the wider actor system, which I'll get onto, represents a microservice, is built on queues. So in a way, arguably, it's halfway between orchestration and choreography. It provides event buses, it provides distributed pub-sub mechanisms with limited guaranteed deliveries. So it's very easy to build a hybrid model of orchestration and choreography with Akka. Now, my advice is that you basically pick according to your requirements when you're doing Akka. Basically, in the system we're building, what we have is a combination. So, I mean, we'll touch on it a little bit, but at the heart of the system, we have a system that orchestrates a flow, but then we're going out to other people's microservices and we're using choreography to do discovery and to allow them to decouple. And this is the start, this is actually starting getting related to a movement called reactive microservices, which is relatively new, but I'm not going to cover off today. Worth noting, if you've not heard of it, have a look at it, because then we're getting into event sourcing and message sourcing, which is very sexy at the moment. Right, so deployment. Joys, joys, joys. So touching on the topic about DevOps, again, reiterating, Agile teams, for me, you need a DevOps specialist, is my view. I mean, it's nice in an Agile team to spread the skill set, but you need at least one person in a team who really knows DevOps. And I cannot emphasize, I mean, I've seen a number of organizations fail with DevOps when they got a centralized DevOps team sitting in another department or building or even continent who centrally manage everything, and then they're not servicing the needs of the development team. But it gets worse because they're not communicating the operational requirements that they're supposed to be representing to the development team. So I really, really believe that DevOps is about embedding this in the whole development process beginning to end. And even having a concept which I've only seen in one place, a DevOps architect, representing that at the foundations of the service that you're building is really important. The continuous integration is very key. Now, just talking about our experience, what we've chosen to do with this so far, and this is still a work in progress, so we've not learned all our lessons yet, is we're using Docker as our single deployable unit. Lightbend is promoting something called Lagom, which is not bad as a rapid start, but I don't think it's as flexible as we would like to do. And as touched on, application server, in my opinion, and it is an opinion, don't. They're too heavyweight for microservices by far. So what we're doing really specifically is we're using Docker with unikernel. I don't know if you've come across it before, which builds you about as lightweight possible a Docker image with just a JVM or just a CLR or just the one thing you need to boot up your microservice or potentially group of microservices. Because I genuinely, this is a religious war for some people. Some people like to have one microservice per Docker image, per unikernel. With care, with caution, if they're cohesive microservices, you've got latency concerns, you've got communication concerns, there's nothing wrong with having several in one Docker container. And of course, the point being that if you restart Docker being so lightweight, you can restart it very easily. It's not a big problem if you need to do a restart and 2 or 3 instances of a microservice are restarted together. But obviously you don't want to have 5 different completely disparate microservices deployed in one deployable unit. But as I say, it's a bit religious. My experience is it's okay to have more than one microservice per Docker, but hey, you will have your own things. So the other really nice thing that I like about Akka is it gives us for free. It's a very lightweight platform, very small overhead, but using a cluster extension, it solves a really, really important problem with microservices, which is being able to scale up and scale down. Because one of the things is that obviously with databases and data stores, you've got to have cohesion in your data, so you need to basically have a sufficiently powerful database. There are ways of solving this as well. That's not this talk. That it can cope with the demands on it. But you may want to scale up and scale down the instances of the microservice addressing their particular data domain, their particular database dynamically. And Akka provides a mechanism for it by allowing you to deploy clusters of actor systems which have identical microservice actors within them, etc., and provide mechanisms. Either you can use a hardware load balancer, more traditional, or you can build your own software load balancers in Akka, and I'm going to talk about some of the components to do that in another slide. So really, really powerful. And then you start getting very interesting then, because DevOps can start becoming responsive at deployment time. You can actually change the way that you approach DevOps, saying, I'm going to have 5 servers and I'm going to have these microservices on it, to say, I'm going to scale, quiet times, midnight, I'm going to have 2 or 3 servers. Busy times, I can scale to 10 or 50 or 100, depending on the groups of microservices and the deployables you have. Right, so the other thing to mention that's very important is versioning, because this is elephant traps all over the place. I will use the term elephant traps for this one. Basically, one of the biggest problems with anything is you want to be able to deploy a microservice independently. You want to be able to do that without breaking the world, because you've got an enhancement, you've got an improvement. The microversioning, I'm still assessing, but there's one core concept in microversioning I 100% agree with. You've got to be able to cope within your microservice architecture more than one version of a service running at a time. because basically you can't deploy a new version of the microservice and break everybody else. So this actually then relates back into monitoring as well, a topic that as a question was asked for, because you need to then be able to judge how you age out your versions and also know which services or which microservices, which groups of teams are using your microservices in order to tell them, get off that old version, I'm killing it in 2 weeks, 5 weeks, whatever your thing is. Now micro versioning is something that I'm still not totally sold on, but it's a number of techniques and a number of concepts where you do tiny increments compatible and support anything up to 5 or 10 versions at a time. Still not convinced of the technology for it, but you really, really have to think about it. And the next level down is already been touched on, is the rolling upgrades. Basically, you should not, in any high availability environment using microservices, install a single instance of that microservice that you then have to take down and upgrade and then replace. If you're doing true high availability, high throughput, 24/7, which is the systems that I'm building at the moment, you need to make sure that you have clustered microservices, that you can take one instance down, upgrade, adding a new version supported, maybe deprecating, and roll the upgrades. So you have a continuous support of the active versions, and you're adding the new version as you go. So really important to make sure your infrastructure supports that. Again, this is great with Akka, because the clustering allows you have a set of seed nodes, you can roll, you can take down a seed node, it will dynamically allow you with the load balancing built into Akka, or a little bit more awkwardly with a hardware load balancer, to redirect the traffic away from the microservices that instances you've taken down without taking down the overall microservice that you're providing. Okay? Right, I got quite passionate there. I span out a lot of words and I talk very fast. Hopefully that wasn't too scary and a lot of it made sense. But this is why we have questions and answers at the end, so you can say, what the hell were you talking about? So, touching on concurrency and performance. So this is a really, really important one. A lot of microservices are built assuming a particular protocol. So Graham alluded to the fact there's an awful lot of HTTP protocol out there, whether it's RESTful or SOAP or whatever else. It's a problem, because if you're building high throughput, low latency, the communication protocol can really act as an anchor on your system. Akka has a very good way of dealing with this, at least from our perspective, because the communication protocols in Akka allow you to decide, as you're deploying your actors and the microservices they represent, to choose dynamically by composing together whether closely allied sets of microservices are deployed within the same JVM on the same actor system, so they can take advantage of in-JVM communications. With the ability to fail over dynamically to cluster communications if they can't find an instance of the microservice they need to talk to locally. And then it's very seamless to then plug in Akka Camel to be able to break the boundaries out into the more traditional protocol worlds, into REST, into SOAP, into FTP, God help you, and into whatever other protocols you need to use to talk to the wider set of services or microservices in your domain. So Akka really provides some nice ways of doing this dynamically and also configuration-wise and runtime. So I've talked about how already actors process one message at a time, so they never ever have concurrency problems. The problem is that real-world systems, you need to do multiple things at once. Okay? Now, in Scala's Akka speak, the equivalent, I'm a Java dev, so I think in terms of executors, the equivalent is a dispatcher. So a dispatcher is basically a thread pool containing your things. By default, Akka has a very nice configuration of core dispatchers for dealing with the core services, but you can build your own. And the way that you typically do concurrency in Akka is that you create pools of common actors Language I'm a bit cautious about. Some of my guys are calling them nano services. I'm not sure that's a good term for them. But basically what happens is they are identical instances. You have a router that sits in front that can then allocate work based on round robin, based on busyness, based on last message processed and responses received, etc., etc. Basically, this then allows you to get concurrency by controlling the number of actors available to service the request to your microservice, or whatever else, however you're breaking it down. So we're using MongoDB. Again, another talk another day if you want to talk about MongoDB. But we have taken like ducks to water to the MongoDB async drivers. So basically, they allow us to perform actor-based processing without blocking, where we're hitting a database, because we basically say, go away and do something in the database and give me a message back when you're done doing it. So suddenly we've removed a whole class of blocking problem from our microservices, which allows scaling. So a number of database drivers are beginning to do this, but equally, if you have to use Oracle, and we've looked at doing it, we've looked at building actor-based systems where basically we have a pool of actors representing connections. These actors have their own dispatchers, so we've got an isolated set of threads to do with a database. So the rest of our microservices and actors and everything else can get on with doing their work while we've isolated the blocking problem of working with Oracle away. So really do think about this when you're working with just with microservices in general, but with Akka in particular. Try and isolate anything that's blocking and slowing you down away behind somewhere else. So here's a gotcha. I don't know how many of you are thinking of working with Akka, but hopefully some of you here came to this meeting because you are. We have a lot of fun. We've been using Java 8 Lambda functions. Java 8 Lambda functions are fantastic because you can pass the Lambda function around between contexts to do things and everything else. However, Akka has a great big fun thing. Their concurrency model assumes that when you're interacting with the actor, you're acting within the context of the message you're processing and the thread on which you're processing that message. With a Lambda function, it's really risky because you can pass a Lambda function out to, for example, a Mongo async database driver and call accidentally a method on the actor that invoke the database call. So just as a gotcha for when you find your actor system does something really bizarre and really unexpected and starts throwing weird errors, do look in case you've managed to pass something like a Lambda function or whatever else over that then causes you to break the Akka concurrency model. So there's a danger there, okay? And finally, a very, very nice little feature of Akka that we have used in certain contexts. We talk about scaling, we talk about having lots of instances of actors with many microservices, all this fun stuff. Sometimes you need just one. One single thing to control, to manage, to determine, to wake up and do something. And in your system, you can't afford to have many of them. I just need to double check that I'm not boring you to death running out of time. Let me know if I'm running out of time, guys. I think I'm nearing the end now. The cluster singleton is a really nice feature of Akka, and even if you're not going to use Akka extensively, it solves a huge problem when you're dealing with clustering. So the cluster singleton, basically, you deploy an actor system on multiple nodes, you group them as a cluster, you say, I want a cluster singleton. Cluster singleton lives on one node, and when that node dies, it comes up on another node totally automatically. I cannot tell you how over the past 20 years I've lost hair to the problem of making sure that a singleton component basically comes up and is available when I need it. And for that one thing alone, I love Akka very much indeed. Right, so finally, I think we're just about there. We're on to a few more topics. Let me just see where we are. Yep, 2 more topics, and these are slightly smaller. So, microservices have a very, very nice feature. Because they are so lightweight, when something goes wrong, just restart the microservice is quite powerful. They're very quick to fix and redeploy. You know, if you've done your DevOps, you've done your I favor BDD, your test automation and everything else, getting a bug fix out to the coalface can be done as little in a few hours, but we're still talking human time to fix problems, okay? So sometimes though, you have time critical processing, and what do you do while a fix is being sorted? It could be that you have a problem that is only occasional and you want your system to recover. You know, it may barf on that one transaction or that one interaction, but everything else is okay. So what happens in Akka is it provides a mechanism of supervision and mechanisms to define strategies for restart, continue or terminate the particular process or actor that is having the problem, so you can then let the rest of the system continue safely and robustly. And this, for the system that I'm building, which I'll touch on, is very, very important indeed. Oh fudge, I said I was running out of topics. I'm nowhere near running out of topics. Never mind, I'll accelerate a little bit if that's okay. What time have I got, guys? Five minutes, 10 minutes, okay. You can tell I've got a lot to share. I love what I'm doing, so I'm trying to share a lot with you guys, and I apologise. So, on top of the fixing, the continue, restart, terminate, fundamentally, actors supervise and start and supervise other actors. When an actor has a problem, it asks its parent what to do and how to deal with it. And then the parent has a strategy for, okay, I want you to continue processing, I want you to terminate processing, I want you to restart processing. One mini gotcha though is the actual behavior for what to do when you restart belongs in the child actor that's being supervised, not in the parent actor. Otherwise you start coupling your actors and potentially your services, microservices as well. So also worth noting, monitoring and alerting, very important. Out of the box, Akka has a number of nice capabilities, but you can also get off-the-shelf monitoring and alerting systems that can monitor the actors as individuals, can monitor the interfaces as microservices and everything else. And there's one, I can't remember its name, I tried to find it again, I've got it noted down somewhere, that is the holy grail for me, that you get an exception thrown. It not only catches a stack trace, it catches the variable values when the stack trace occurred. And that works with Akka, but it also works with other JVMs. Look into it, it's great. When you're dealing with the outside world, so you can get problems. You're calling out to a third-party system, you're calling out to another microservice, you got a problem. Akka has the circuit breaker pattern built in as a first-class citizen. What that basically does is it provides a mechanism for detecting when there's a problem, failing fast, so you can start applying back pressure and say, I've got a problem, don't send so many messages to me, and detecting when the problem has been resolved so you can continue business as usual. Again, thinking about this sort of thing is really important. A pattern that we've started doing is with our actors, when we're going out to time critical things we want to time out, we create a supervisor actor, we spin up for the moment of the request that effectively starts a timer using the Akka scheduler and says, okay, I'm responsible for seeing this request through to termination, either because I've got a response or because it's timed out and I'm saying there's been a problem upstream. Right. Next, moving on, this is very much more a concept to understand. Throw out my notes. ACID transactions don't work with microservices. It's a huge topic. I'm not really going to spend very long on this, but basically ACID, as we understand it, should be superseded with ACID 2. So if you're working with microservices, hopefully the architects, the designers, and your teams and yourselves are looking at the concepts of saga transactions, long-running transactions, ACID2 transactions, where you're dealing with eventual consistency, you're dealing with idempotency because messages may be repeated, you're dealing with compensation, i.e. basically undo the work you've done because there was a problem doing it, and eventually, never forget, you may have to do a manual fix, so make sure you've captured enough information to do that manual fix. Because it will happen. There is no system I know in the world where a human being doesn't go in with a spanner. Security. Do not underestimate this with microservices. Basically, what I've taken to doing as a wider architect rather than the work that I've been doing specifically at Icon is saying that we must define each microservice's security characteristics. You can help yourself by creating isolated subnetworks for deployment, but you've got to think about things like encryption of the messages between the microservices. You know, in certain contexts you don't have to do that, in others you do, and at rest as well. And this really impacts your microservices, the technologies you choose, etc. You also obviously need to front with secure gateways and UIs, but there's one thing. I'm an old fart, so you can see this. There's a fantastic book that I have read and keep on my bookshelf, Secure Coding Principles and Practices. This was built by a bunch of guys written by a bunch of guys who wrote various versions of Unix, using this composable model that Unix has, where you can pipe things from one command to another to another. And this is what we're doing with microservices. We're composing services and flows and systems out of microservices. And the lesson these guys learned, and the lesson you guys are going to probably be learning when you publish your microservices and your systems based on microservices, your system is only as good as the weakest microservice from a security perspective. It's really, really important. So basically, you've got a microservice that can delete the contents of a database. Some hacker may well work out how to get a command from a service that you thought is totally innocent all the way through to delete that particular data store behind that particular microservice and wreck your system, or perhaps pull confidential data out. Do not underestimate the challenges that microservices are going to give to you from a security perspective. Right, this really is the last slide. So doing it back to front, I'm really going to skip this one so you guys have a little time for questions. Icon Solutions that I'm working with at the moment is a financial sector IT consultancy. We've got deep real-time payments expertise. We've got some of the people, myself included, who built real-time payment systems around the world, like IPS, who are in at the foundations of the clearinghouse in America, so IPS for Singapore, etc., etc., built faster payments and have been looking at value-added services in terms of real-time payments. What we're building at the moment, our first product, is the instant payments framework. Now, instant real-time payments is a tricky word because we know that real-time programming is a whole other order of magnitude of speed. But fundamentally, what we've been doing is we've been building an orchestration system composed of microservices that models payment flows for the upcoming real-time payment world as finite state machines. Reason why we're doing it in microservices and finite state machines is it's very easy to compose new business processes for our customers, for the banks that we're selling to. It really provides a clear approach to dealing with their diverse internal architectures because we can create bespoke actors and microservices fronting their legacy systems and everything else, providing stand-in processing, providing failover recovery and all sorts of fun things there, etc., etc. So it really helps us deal with those diverse structures, as well as the Camel integration, which does a lot for us. And we chose Akka as well. Basically, the concurrency model is great for what we're doing with real-time payments, and it's very low latency. It's lightweight, which we love. It's cheap as well, which I probably shouldn't say, but my boss loves that to pieces. And the Java support that people working at banks love to pieces, because an awful lot of coders at banks are Java coders, not Scala coders. Right. Sorry about the rush at the end. Questions, I say this to everybody I ever work with, the only stupid question is the one that doesn't get asked. Don't be embarrassed. So your hand up was first.
Akka is based on the reactive manifesto, and yep. I think that based on solving a problem in a lower level, where yep. even like thousands of actors created sometime. I've worked on Akka. You will see like for Ladbrokes I work. So in a Saturday at 3 p.m. there are like 50, 100 football matches are going on. And you want to display like in-play thing, then you can create like 200 of instance of actor and you can display it.
Absolutely.
Microservices are based on much higher level, where yep. you want to solve the problem on an enterprise level. You want to have a sales division, you want to have a inventory, you want to have a payments, and you need a framework which will deal with that one.
I
So-
sort of half agree,
let me
half
complete
disagree.
this.
Yeah, absolutely.
Yeah. So when you want to try to solve microservices using Akka,
Yep.
I don't think that fits the best. It's meant to be something else. It's meant to where you want to create thousands of thread actors, and you don't have to deal with threads.
Well,
The main thing we get to Akka is we don't have to deal with threads. We don't have to create multiple threads in Java where we want to create. And when we say that we want to create microservices using Java, which is object-oriented programming again, and no matter what we do, how much layer of abstraction we have, and the underlying thing we are dealing with threads. So in terms of microservices, we need some framework. I agree with the domain-driven design and all stuff, but we need some kind of framework which sits on like much higher level as compared to Akka. Akka can be a part of microservices, or you can say it's a nano services, and keeping one actor in one of the Docker container, which will be deployed again in Azure or in your Amazon cloud. That will be like, I don't think that will be cost effective.
So fundamentally, I think I misspoke, or not as the case may be. I typically favour, basically I talk about an actor system at Docker level, not an actor at Docker level. That's an important distinction to make. So an actor system, perhaps I didn't make clear, is effectively a group of actors. Now you can, I mean, it's an anti-pattern to have one actor per actor system. It's also an anti-pattern to have an actor system that does 10,000 things at once in terms of different business domains and different business services. So this is why also I was talking about having actors, multiple microservices in one deployable unit. I actually very much like having, for example, from a microservice perspective, this is what I was talking about, a group of actors that provide a microservice, and then I have, using Akka, the ability to deploy that group of actors either on the same actor system as other groups of actors as microservices, or move them over using Akka clustering and the Akka communications protocols, and have the actors deployed on different actor systems. I also talked about heterogeneous processing, in that your microservice, you may have one microservice built in Akka as a group of actors, potentially deployed in one actor system or several, etc., or having a microservice or a separate service built in a completely different technology. So Akka isn't a panacea for microservices, but it's a good way of building composable, scalable microservices, in my view.
So that means you need to have all the developers, all your team dependent on one technology. If you're using Akka for Java or Akka for .NET, then you need to use that. There is no Akka if I have to use in Node.js. I work in Node.js. There is something called RxJS, which is reactive programming. And I thought that is based on the streams of data. If you're Netflix or...
But have you looked at Akka's reactive microservices stuff? That's really, they're beginning to crystallize some of the patterns.
I worked the .NET port of Java.
Yeah. Okay, so we probably need to give other people a chance. We're having a discussion rather than answering a question. So I see Graham's hand, and I saw that gentleman's hand first, so maybe you first.
Yeah, with regarding to the security, we know that in the microservices, we don't prefer using the SOAP protocol, and we rather go for the REST protocol.
Yep.
And in that scenario, how do you make it more secure? I mean, what way Akka can...
So Akka doesn't really, in my view, Akka doesn't address security directly. It provides you the tools to build your own security solutions. The integrations it's have using Camel, if you're doing that, or everything else. But the protocol, so for me, security isn't just the protocol. So RESTful JSON, as a protocol, there's a number of ways of securing it, whether you're doing an encrypted VPN, you're doing an encrypted HTTP connection, whether you're doing all that. Then there is the view of security that I was talking about, aside from the communications, which you can encrypt, using Akka and Camel and the Akka HTTP, you can build all that stuff, is also thinking about what your service does internally, that somebody has said, I can invoke this service, but because of the interaction, somebody can invoke the service to call a method you never expected them to do. And that actually, again, Akka doesn't solve that. Really, that was a warning, not a solution, if you see what I mean. So Akka, from a security perspective, I mean, you've got experience as well. I don't think it's got a massive answer to security. Really, it's your wider microservices architecture where an actor may be built, a microservice can be built out of an actors that addresses your security. Okay. Graham was next, so sorry, then I'll get to you.
How Akka is now handling ordering the messages and the replication?
Okay, so replication, so not something we've used. So messages going onto an actor queue are ordered in the order that they arrive at the actor queue, but there is no definition of ordering built into Akka because it's concurrent. The moment you impose ordering, you introduce a bottleneck and you introduce something that's got to impose your ordering. And you can build things to do that for you, but it's not the way I would design anything in Akka or even a wider microservice architecture relying on ordering. Now, putting that to one side, what there is, however, in Akka is support for event sourcing and journaling. So where you can actually say that I received these events or these messages in this particular order and store them so you can replay and recreate and potentially recover from certain failure modes. But the ordering is not an external imposition, it's an ordering in terms of recording what happened in time after the fact, not before the fact.
So you talk about failure, how the Akka is handling. If actor is failing the processing message,
Yep.
how does it going to handle
It gives you the tools to define how you want to do that. So fundamentally, if it fails, if it's got a problem with a message, first thing you decide is this an exception that you want to throw because the actor has no way of coping with it, in which case this is a fundamental failure that it's received a message it never expected. Oh my God, panic, panic, my internal system has reached, internal state has reached a state I can't recover. So that goes up to the supervisor strategy to say, forget it, restart, and pick up all the messages you've done while potentially logging out the problem with the message. Or in your design, you may choose to say, well, actually, this problem is a business thing, so I will have a message that I will pass on to another actor to handle this failure mode or this problem. So kind of like you do with dead letter queues and things like that. And built into Akka is the concept of a dead letter queue for unhandled messages as well. Okay, sorry, Graham has put his hand up several times now, and I'll get to you, Tomasz, as well.
Your point about the one of the funny things for us going from Java to Scala, you made a very good point, sir, about the higher performance asynchronous drivers for the database. I really like the performance. I have a tough job selling that to the developers of the business sometimes. There's a lot of fear that because they're asynchronous, what if it falls over halfway through right into the database? And you can probably deal with that by compensation or idempotency or something like that. But do you have any rules of thumb for a feel for when you might? Let's say there's a balance between performance and a traditional driver where, hey.
So what we tend to do is, for where performances are, we use asynchronous for preference. And we use traditional drivers where we need absolute certainty then and there in that split second. So it's split second certainty. Most of what we're doing, we're happy with eventual consistency measured in microseconds. So we say every database interaction must always return a message. And we then wrap that in, I talked about this concept, a pattern that we're using now of a request administrator that says if I haven't got a message after a certain period of time, panic and take appropriate action to say to the originating actor, you know what, something's gone wrong, now go and deal with the problem. So it will give you, with the Akka timer, your resolution is down at milliseconds, though we have also looked at resolution for timers going down to microseconds for certain really low latency stuff, but that's quite bespoke stuff we're looking at. That's not core Akka. Is that a good answer? Right, Tomasz.
How many services did you start with? I would hope that with Akka you can basically start just with one, and when you know what you're building, you can start splitting that because you can just move the actors between the different systems. And
So we started with one actor system, but we were already composing the domains and considering the domains and the microservices already from the very beginning. But we started with one actor system, and then we used the Akka clustering so we could then start pulling and demonstrating that our microservices were properly independent into independent actor systems on their own. Well, actually, they weren't on their own physical nodes. We just deployed multiple instances to one box so that we could start proving the composition and started proving that we could trivially have a microservice talk to a microservice using native JVM communication within Akka, or we could very simply redeploy it and use the intercluster communication mechanisms, or further then expose that microservice using Akka HTTP or Akka Camel with a completely different communication protocol in front of that. But it wasn't, we started with a monolith and we decomposed it. Instead, we started with an actor system and decomposed groups of actors that composed to create microservices.
okay.
Sorry, we've got a question over here as well. I think we're hidden a little bit.
Yeah, no worries.
If I understood correctly, you said it does not support acid. Is it correct?
Does not support
Acid as atoms.
atomic acid transactions. Absolutely. So what you can, within a single actor, you can, because basically most transaction managers are single-threaded. So basically they put their context of the transaction on that single thread. And so when you're running in, for example, a transaction manager on WebSphere, WebLogic, basically there's a single thread of operation that runs through from when you pick a message from a JMS queue in the transaction through to committing, or putting the record in the database or the set of records, all the way through to the final point where you commit your two-phase commit and everything else. And I don't know any open source transaction managers that aren't based on the idea of a thread local context. Now the problem with Akka is you've got no guarantees on the thread of execution that is flowing through the system. So what we have been doing is we've said, actually, you know what, we're going to throw out ACID anyway. ACID, particularly two-phase commit, supposed ACID, which that's another debate, what is two-phase commit? Is it really ACID at all? There's some good blog entries on that. But basically, we decided to throw it out altogether because we were building a microservices architecture. And the moment you deploy microservices to two different nodes, you've broken the ability to do ACID transactions anyway. So we've just embraced the non-ACID nature in the pursuit of the scalability, in terms of the self-healing, in terms of the flexibility to change, individual microservices and version them. But
you are doing a load balancing, and the same version of microservice is running on two different
absolutely.
nodes. And if say two different users were updating the same record at a particular instance of time, so then one of them went to microservice A, and another one went to microservice B.
Yeah.
In that case, because it's not blocking, so which one of that will be the one which will prevail and visible to the...
So we're talking non-blocking drivers, we're not talking non-blocking databases. There's an important distinction. So we're using MongoDB, so we're solving this in a classic NoSQL way, in that we use the MongoDB update mechanism where you can basically do an update and check based on an assertion. It's like Oracle select for update. So fundamentally, we're doing an optimistic locking mechanism that we built, and it's really seamless the way we built it into our actor system. So that handles that contention. But obviously, within a single actor, you can start a transaction and block and everything else. So you can do multiple updates in a more traditional Oracle database, etc. But it always has to be scoped to a single actor's message context and a single thread if you want to use a transaction manager. Okay? Okay. Oh, other one?
Just about synchronous messaging. In a typical messaging system, you achieve synchronous messaging using correlation ID or temporary queues.
Absolutely.
Does Akka support this synchronous messaging? If so, how?
Yep. So Akka Camel, out of the box, basically Camel supports it, so Akka Camel supports it. So very simply, the only bit that you have, so fundamentally what Akka does, okay, this is getting the gory inner workings of Akka, but say you've got a message coming in with a correlation ID that you have a reply to set up, configured in your Camel configuration, and this does vary from JMS or messaging server to messaging server. What happens is, it's kind of like the request administrator I alluded to with the timeout. It has a temporary actor created at the point that this message with correlation ID comes in, and you can pass the reference to that actor throughout the lifespan. It's called a sender reference, throughout the lifespan of processing this message throughout the microservice actors that are compose that microservice. And then when you want to send a reply back, you send it back to that sender reference. And then that Akka Camel, as long as you configured it correctly for your particular transport, will then sort out reapplying the correct correlation header and passing it back out. Okay.
What is the biggest difference using Spring with Camel and Akka and Camel?
Oh, right. Very good question. So, to be honest, in my world, we've really not decided, because we actually use Spring and Akka and Camel all together. So Akka Camel's, in its base configuration, it primarily uses Camel not to compose, I forget what the correct term in Camel is right now, I have occasional aphasia where I drop words, but you know how you can compose several things, create a flow or a root or whatever, roots in Camel. So what we have, so Akka Camel primarily focuses on Camel providing integration endpoints in and out of Akka. So that's the biggest difference in many ways, in that the root consists of an Akka Camel endpoint, your microservice and your Akka actors processing, and potentially then either going back to or going on to another Akka Camel endpoint. However, we also do have the capability to use Spring Camel where we want to do something not using Akka in our system. Okay?
I have a point.
Do you have? Sorry.
Yep.
What's your DR strategy? Do you have actor systems running in 2 data centers?
Our DR strategy is actors running in as many data centers as bloody possible. So Akka clustering has a nice thing, because one of the classic problems is quorum problems, where you basically got to have the right number of actors and everything else to do that. Now, because Akka is not designed to be stateful, so you don't have the same problem with databases and split brains. But where you're dealing with Akka Camel, you can set up your configuration up so you've got a certain number of seed nodes, a minimum number of members to address potential split brain if you're using cluster singleton, which I love still. But then, aside from that, we just deploy to as many data centers as possible. And Akka will discover, etc., etc. The only thing I would advise though, very strongly, is it's very easy to communicate across cluster nodes. It's really easy to jump out of your local actor system into another actor system to get to another microservice, etc. You do want to look at configuring for proximity, so that instead of accidentally going across the continental United States to the microservice instance on the other side of the world or other side of the continent, that it stays within the same data center as much as possible. That's the only drawback to that flexibility. Okay.